Okay, now we move to the application of integration. Okay, so what they can do. So in integration, okay, we can use to find the area and the volume of any function. So first here, okay, we look at the to find the area between the curve and the x-axis. Okay, the most basic one. Okay, this is the curve and this is function. Sorry, this is the axis. Okay, x-axis or y-axis. Okay, so first of all, we'll be looking at the curve, okay, between the curve of the function and the x-axis. Okay, so the horizontal one. So if f is continuous throughout, okay, from A to B, from A to B, then the area of the region between the curve fx and the x-axis from A to B is given by A, okay, from the A to B, y dx. Okay, y here is actually your function fx. Okay, so simply I could change the formula here, A to B fx dx. So the function of x, okay, we are integrate to the with respect to x. Okay, if you look at the sketching over here on the left side, okay, we see the curve here is above the x-axis. Okay, so this curve, okay, which is the function, okay, so the area under this function, the area under this curve, okay, which is from A to B, okay, so we're gonna use this formula. Okay, so on the right side, okay, the sketching of the curve is below the x-axis, so the area would be negative, but we must put the modulus sign here, okay, which is, we know the area is must be always positive. Area between the curve and the y-axis. So if s continues throughout, okay, from C to D, then the area of the region between the curve, okay, of the function y and the y-axis from C to D is given by, okay, a equals to integration from C to D x dy. So the same, x here is actually the function of y. So I put g here. So you could just simply, okay, you could change the formula from C to D gy dy to integrate function y with respect to y. Okay, these two sketchings below here, okay, so we could see on the left side here, okay, the curve is on the right of the y-axis. So the area under this curve, so we refer to the y-axis. Alright, so the area under this curve, so which is A from C to D, so we're going to use this formula. Okay, so the same goes, okay, when we look at the sketching on the right side, so it is actually on the left side of the y-axis. So y-axis has the reference line here, so the area under this function, okay, so you'll get negative, then we put modulus here because the area is always positive. Example 14, sketch the graph of y equals to x multiplied by x minus 2 from the domain negative 2 to 4. So this graph, okay, we could see the function is a quadratic function because when I expand, okay, become x squared minus 2x. So positive quadratic. Okay, and then the root here, so I know the x-intercept, okay, is going to be 0 and 2. Okay, so I just simply sketch from negative 2 to 4. So negative 1, negative 2, 1, 2, 3, 4. Negative 2 is 0, 2, 4. This is y-axis and the x-axis. Okay, so we know that this graph would be, looks like smile, and then the roots is at x equals to 0 and x equals to 2, which is the x interception, 0 and 2. Okay, what else? Okay, so you could plot, okay, if you are not sure about what will be the graph looks like. So from negative 2, when x equals to negative 2, so negative 2, negative 2 minus 2, negative 2 is 8. Okay, so negative 2 and x equals to negative 2, so about there. And then when x equals to 4, 4 minus 2, 4, 2 also 8. Okay, so somewhere here. Okay, so the minimum point, So I could just simply sketch the graph. So this will be your graph. Okay, will be looks like it's smiling. Okay, positive quadratic. Okay, sketch the graph. So I have sketched, then it's done. So next question, what is the area B? Here we look at B. What is the area between the curve, between this curve and the x-axis, bounded by x equals to -2 and x equals to 2. Okay, we must first put the limit line first. Okay, change back to the blue one. Okay, here is 2. So from -2 to 2. So from here to here. Okay, so the question asking to find the area between the curve and the x-axis. So the curve and the x-axis. So we look from the -2 to 0. So the curve here, okay, the green one, here the x-axis. So this is the area under the curve, okay, and then from 0 to 2, okay, so between curve and line, so between curve and line. So the red one, so the low rate is there, so we could see clearly, okay, this is the question asking about to find the area between curve and x-axis, okay. Okay, so the area is A. Okay, so since we look at the region bounded here, okay, first part from -2 to 0 is a positive area because it is above the x-axis, okay, while from 0 to 2, okay, it is below the x-axis, so the area would be negative. So we just put modulus later. So slowly we begin from -2 to 0 of the function dx. This is the formula, and then we plus, okay, we add up with the next domain 0 to 2, okay, of the same function, because here only one function involved. So now we put the function -2 to 0. So the function is x minus 2 dx plus, so we put modulus here, okay, as I said, okay, it will be negative. So because it is below the x-axis, so the function is x minus 2 dx, okay, equals to, okay, I haven't yet integrate them because it is easier if I expand this first. X squared minus 2x of respect to dx plus from 0 to 2 x squared minus 2x dx. Okay, so now we integrate them. So x to the power of 3 over 3 minus 2x squared over 2. So from -2 to 0, square bracket, plus, so the same here, x power of 3 over 3 minus 2x squared divided by 2 from 0 to 2, okay, equals to, so I will be straight away, okay, to the soft one, which is 20 over 3, okay, for the left part here, plus, okay, so the modulus one, okay, so you'll be getting here -4 over 3. So you try out, guys, so make sure you try out them. So the answer, the final answer will be 8, since this is area, so 8 unit squared. Now we look at the example 15. Find the area of the region bounded by the curve y equals to x cubed. Okay, x to the power of 3 plus 3. The y-axis, the lines y equals to 2 and y equals to 4. So now we have cubic function. So do you still remember how the graph will be looks like, okay, for the cubic function? So to find the area of this region, okay, you must first try to sketch the graph. Okay, if you don't, then you couldn't see, okay, where will be your beginning limit and the ending limit, okay, to find your area. Now try to sketch the graph, okay, even though they did ask to sketch the graph. So the cubic function, so plus 3, so the y-interception here is a 3, when x equals to 0, y equals to 3. So here is a y-axis, so I scale, here is a 1, 2, 3, 4. 1, 2, 3, 4. Okay, the lines y equals to 2 and y equals to 4. So I use the different color. So here is a y equals to 2, and then for y equals to 4, so I choose orange. Here is y equals to 4. Alright, so the graph x squared plus 3. So the graph is the red color. So the positive cubic function and the positive, okay, so we started from here. Okay, so the interception here and here, so we could just substitute into the function. Okay, to know the interception here between line and curve, okay, we just substitute y equals to 2 here. So y equals to 2, 2 equals to x cubed plus 3, x cubed, x power of 3 equals to negative 1. So x equals to negative 1, here is a negative 1. So while at the point here, so interception when y equals to 4, so 4 equals to x cubed plus 3, 4 minus 3 is 1, so x equals to 1. So we have done, okay, sketch our graph. Y equals to x cubed plus 3. So what will be the region? Okay, look back to the question. Find the area of the region. Find the area of the region bounded by the curve, the y-axis, lines y equals to 2 and y equals to 4. So there are 4 bounded line here. Okay, we have curve, we have y-axis, and 2 lines, which are y equals to 2 and y equals to 4. Okay, so I want to change the original color of which will represent of every line here. So y equals to 4 is orange color. So y equals to 4, oh, it's an orange. Y equals to 4 is an orange. And then the red one is a curve. So curve is the red one. Y-axis is the blue one. Y-axis, okay, blue color. Okay, and then the other one, the y equals to 2 is purple. Okay, so we have purple, blue, red, and orange. Okay, so we gotta find out, okay, where would be the region located. So, okay, so as we look at the y-axis as a reference, so this would be the region under the curve. So y, okay, we see here, okay, there is a red color, orange color, and blue color. So this is the curve, the red one, orange, y equals to 4 line, and then the blue one is the axis, the y-axis. And then the shaded here also, okay, we see the bounded region, the region is bounded by y equals to 2 line, the axis, the blue color, and the red one is the curve. So these two are the regions bounded by the curve and the y-axis. Okay, if you want to get clear of this, okay, to get clearer info, so you see your tutorial lecturer, okay, and discuss with them. Okay, so now straight away, okay, want to find out the area. So the area A equals to, so the limit is from 2 to 4, but there are 2 regions here, so we choose the lower limit. The lowest is from 2 up to 3, okay, of the function. So function, oh, alright, so we haven't yet changed the function. The function here is y equals to x power of 3 plus 3. So why must we change the function? Because here I want to find the area, okay, and then I want to integrate with respect to the y, which is on the y-axis. So I must change the function x into the function y. So x power of 3 equals to y minus 3. So x equals to y minus 3, the cubic root, so I change to index form. Okay, easier to integrate, so 1 over 3. So this is now, okay, I've changed the function into the y, as into the function of y. So here is y minus 3 with respect to y. Okay, that is why we have to change the function into the y function. Okay, we have another region from 3 to 4. Okay, also the same function, which is y function now, function y. So y minus 3 to the power of 1 over 3 dy. Okay, straight away, okay, we're gonna integrate this function. So y minus 3 1 over 3, so it becomes y minus 3. So 1 over 3 plus 1 is 4 over 3. 4 over 3 divided by 4 over 3, and then this is a linear ax plus b, so derivative, not derivative, we take the a is 1, and then the limit from 2 to 3 plus, okay, so here also, okay, we're getting the same integration, 3y over minus 3. Here is a 4 from 3 to 4, so equals to 3 over 4 plus 3 over 4. Okay, the final answer is, okay, will be 3 over 2 units squared. On this side, okay, if you try yourself, okay, you'll be getting this in negative. Okay, you must put modulus, because since the region is on the left side of the y-axis. Okay, so I put modulus here. So the actual answer here is a negative 3 over 4. So when I put modulus, it becomes positive. So 3 plus 4 plus 3 plus 4, which results to 3 over 2 units squared. Can I ask you, can I find the area with respect to the x-axis from negative 1 to 1? From negative 1 to 1. Can I find the area from negative 1 to 1 with respect to x, which means I will stay using the function x? Can you? Okay, so you may ask this question to your tutorial lecturer.